Welcome. In this video, we are going to look at problem 55 from chapter 18 of College Physics 2E by OpenStax. We have 2 point charges and we know how far apart they are. We need to find where the electric field is 0 between them and what the electric field is halfway between them. Let's start with a figure. Okay, we'll put the first charge here. So we'll say Q1 is 25.0 microcoulombs. We can say X1 is 0 meters. Over here, we have Q2 is 45.0 microcoulombs. X2 is 0.500 meters. The R between the two charges is X2 minus X1 for the 0.500 meters. Let's see, we can say to the right is positive X. Okay, we're just going to pick some random spot X. And we're just guessing that this is where the electric field between these two charges is 0. That's what we're going to be solving for. Okay, so these are both positive charges. The electric field is away from the charge. So at X, we can see the electric field due to Q1 is going to be this way, to the right, towards the Q2. So there's our E1. Okay, the electric field due to Q2 is going to be away from Q2, so pointing towards Q1. So E2 is pointing like that. Okay, so what we can write down is that E1 is K Q1 over X squared, because Q1 is a distance X from the point. It starts at 0. And this is in the plus X direction. The E2 is K Q2. We need the distance between Q2 and the position X. So that's going to be R minus X, and we need to square that. This one is in the minus X direction. Okay, so what we have is E1 minus E2 is 0. So adding the E2 to both sides, E1 is equal to E2. Okay, we can substitute for the E's. We have K Q1 over X squared is K Q2 over R minus X squared. Okay, so both sides have a K. We can get rid of that. Then cross multiplying, we have Q1 times R minus X squared is equal to Q2 times X squared. All right, let's divide both sides by Q1. We've got R minus X squared is Q2 over Q1 times X squared. Now we can take the square root of both sides. So we have the square root of the quantity R minus X squared equals the square root of the Q2 over Q1 times X squared. Okay, this means the R minus X, and we will choose the positive square root on both sides. So we'll have Q2 over Q1 times X. All right, we need to gather the X's on one side. So let's add X to both sides. We have R is square root of Q2 over Q1 times X plus an X. Okay, we can factor out that X. We've got the square root of Q2 over Q1 then plus 1, and where we have factored out the X. So if we multiply that back through, we get the line above. So now solving for X, we see that X is the R divided by the square root of Q2 over Q1 plus 1. Note the plus 1 is not under the radical sign. Okay, so substituting the numbers, we see R is the 0.500 meters. Okay, Q1, let's start with Q2. Q2 was the 45.0 microcoulombs. Q1 is the 25.0 microcoulombs. Units are going to cancel, so I'm not even going to write them down. And then we have plus 1. Okay, I did this computation, and I found X is 0.2135 meters. So to 3 sig figs, we can say X is 0.214 meters. This is measured from, let's add that in, measured from Q1, which is the 25 microcoulombs. Okay, so that's where the electric field between them is 0. Now in part B, we want the electric field halfway. So if we have our Q1 here, our Q2 here, this end is 0, this end is 0.500 meters, and then at 0.250 meters. We want to know the electric field at that point. Okay, the E1 is still pointing away from Q1, and the E2 is still pointing away from Q2. Okay, so the electric field at the 0.250 meters is going to be E1 minus E2. Okay, so this is going to be KQ1, and we can put 1/2 of R, that quantity is squared, minus KQ2, this one's also at 1/2 R, and that quantity is squared. Okay, this time we can't cancel because we have E on the other side. But we can factor out the K, and we can factor out the 1/2 R squared. We're left with Q1 minus Q2. All right, so K is 8.99 times 10 to the 9 Newton meters squared per coulomb squared. We've got 1/2 of the 0.500 meters, and we're going to square that. Then we've got the 25.0 microcoulombs. Okay, micro is times 10 to the minus 6. We need to subtract 45 microcoulombs, so 45.0 times 10 to the minus 6 coulombs. Okay, I did that calculation. I got minus 2.88 times 10 to the 6 newtons per coulomb. So we can say the magnitude of E is 2.88 times 10 to the 6 newtons per coulomb. Note, by saying magnitude, I've stripped off the minus sign. Another way to say magnitude is to put the E in with absolute value signs around it. Now the direction. Okay, we found a negative x direction, so that is back toward the Q1. So we can say toward Q1, which is the 25 microcoulombs, because we decided that was Q1. And that's our answer for part B. All right, let me know in the comment section below if you have any questions or if there's other problems you'd like to see me solve. And thank you for watching. Please like and subscribe, and I will see you in the next one.